Okay, everyone, welcome to Rigging 2. So, Rigging 2. Remember last week, or I guess 2 weeks ago, because we had spring break, we talked about blend shapes, creating a skeleton, and creating IK handles. This week we'll be going over creating controllers, constraints, and skinning. So, before you start doing these things, before you start creating these controllers, before you start doing skinning, make sure that your model is 100% complete. Manifold geometry, all vertices should be connected. There shouldn't be any holes. You want relatively good topology by this point. Um, if you don't have good topology and you start rigging and then you try to change the topology, that'll create problems with the skinning. You'll have to redo the skinning again, and it just kind of creates a mess. So we recommend having the good topology already done by this point, especially around where the joints where you plan to put your joints, typically around your elbows, your wrists, the knees. Uh, these are all things we went over in ranking 1. So, yeah, don't forget adding extra edge loops near the joints or joint areas if necessary, if you want them to bend more smoothly. And then additionally, make sure you delete non-deformer history at this point. Deleting history after you bind the skin and add skinning can undo the skinning you've just completed and basically will delete all the work that you've done. So please do that before you start doing the rest of what we're about to talk about today. Make sure your outline is clean. You should name all your meshes, all of your shaders, all the rigs and the joints that you put should also be named, and eventually all the controllers that you'll be making today should be also named. Remove all non-essential objects, random downlights, random reference images, empty transforms. But yeah, any unnecessary objects that are not needed in this scene should be removed. It should just be the main character that you're going to be rigging for this file. And lastly, make sure to group all meshes together to one top level master group. And then make sure to name this group the name of your model. This will just make overall like skinning and stuff easier. Change and adjust any pivots if you need to. UV wrap your model if textured. It's painful to change the UV map after skinning. But yeah, again, delete the non-deformer history. Okay, moving on to controllers. So from your homework, you should have this Fox model, just a bunch of rigs. But you don't want to actually interact with just the rigs. Giving these controllers that you'll see right here, you see this round circle, all these other round circles. Over here, you have the eye controllers, more of the head controllers. All of these kinds of controllers just make it a lot easier to interact. Instead of having to try to click each individual rig, you can just click a controller, and this will move the rigs accordingly. Production rigs are typically really complex. They often have a mix of joints, blend shapes, and fancy vector math that the artist should not be exposed to. But in this case, here, as you can see, here's Judy Hopps from Zootopia. All of these controllers can do many different things. Control the eyes, control the face, literally stretching the cheeks, opening the mouth, moving the ears, stretching the ears, and same with the hands, etc., and the legs. All of these things can be done with this model just from these controllers and the rigs themselves. So it's really important to actually get a pretty good rig. Of course, we are in basic, so we are not expecting this complex of a rig. Um, but this is kind of the general idea of like why it's important to have these rigs and these controllers. So never animate joints or meshes directly. So this is what I was saying earlier. You shouldn't really have to be touching your rigs to animate. You should only be touching your controllers. Artists should only need to interact with the controllers to animate any object. Yes, any object. So you should not even be animating a cube. Um, if you're going to animate a cube, you want to put a controller onto the cube, and then you can move the cube. Because controllers can also be attached to not just rigs, but also objects. But yeah, rigs can exist for non-character objects too. Artists should only interact with the controllers for that rig. So car rigs, door rigs, camera rigs, shader rigs, all of these rigs should be animated. All these rigs are what we are using to animate these objects. We do not animate the object directly. You want to put a controller on the object and then control that using that controller to animate the object. Do not animate the object directly. So just make your life easier. It's a lot easier to control an object using a controller. It's also just easier to animate using the controller as well. So controllers are made with NURB curves. NURBS stands for non-uniform rational B-splines. You don't really need to know what NURBS means, but these NURBS curves are like these lines objects here that you see in this picture below. They aren't just circles, as you saw prior here. There's like custom controllers where you can add arrows or kind of like triangle shapes, sharper circles, um, squares, quarter circles, and yeah, you can just pretty much make any kind of shape with these kinds of controllers. But yeah, they represent pure mathematical smooth surfaces and other stuff we won't really get into. Again, we don't need to know this too much because this is basic, and as long as you know what you're using it for, it should be fine. NURBS are typically not renderable. They are only there for artists to work with in a scene. Once you render, they will not be visible. So, after you've created your skeleton, typically you create controllers. Make sure the controllers follow the same parent-child hierarchy as the joints. You want to name all of your controllers, move the controllers into place, freeze the transformations, and then constrain the controllers. We'll talk about constraints in a second. Uh, but yeah, really, really important to make sure the hierarchy is the same. I'm going to show you guys this in a demo later on. And also, you want to make sure to name your controllers so you actually know what they do. Controllers will typically be named called like NURB Circle 1 or NURB Circle 2. Um, Not very obvious what that means. It's really important because just like with how rigs can vary in number um, in models, sometimes you might just have like one or two to three or maybe five rigs where you can easily tell where it is. Some other models can have over 40 rigs, over 40 controllers. Some models even have 1,000 plus controllers. So it gets really really complicated with like how many things are going to be in your model. And it's really, really, really important to name those things because, again, you want the artist or the person animating your model to know exactly where everything is. It's also important to freeze transformations because otherwise, if you set the coordinates to 0, 0, 0, they'll return to exactly when you first made the controller and not where the rig is or where you put the controller and where you want the controller to be. This is really important. Please do not forget the freeze transformations. It's very easy to forget this step. Okay, so why is controller hierarchy important? Again, remember how we mentioned that joints follow a hierarchy, right? That's how they're connected. When you create your controllers, they should follow the same hierarchy. In an FK joint system, remember that the top joints affect the rest of the joints below. Your controllers should also reflect this because you'll also probably have controllers on those other rigs, and if you do not create this parent-child hierarchy, those controllers will not follow, and then actually the rig will stay behind if you move one joint in the hierarchy, and there's some other joints below it in the hierarchy. Okay, constraints. So there's a couple constraints that we'll go over. Constraints are how to tie our controller to our joints. And you can also use these for objects, I believe. But yeah, typically we use these with our joints. So yeah, there are various types of constraints, and each of them have their own situational usefulness. Additionally, many advanced rigs use custom constraints that are programmed in by rigging artists. But again, we won't really go too much into that. We'll stick to the basics here because this is supposed to be introductory. So okay, so the parent constraint functions to parenting something in your outliner hierarchy. The child object constraint will inherit all movement and rotation from the driver object. If you constrain the controller to the object directly, you should be able to translate, rotate, and scale that object. If you parent it to the rig, it can rotate, translate, but it won't really scale because what ends up happening is it's going to try to scale the rig, but scaling rigs don't actually do anything. It will scale. If you want to scale the object, you do need it to attach to the object, or which I'll talk about in a bit. There's also a scale constraint. Um, so you may be wondering, well, if it can rotate and if it can translate, why not just parent everything? What's the point of adding any other kind of constraint? Your joint should already be parent to your other joints, and you can't assign more than one parent to an object. A parent constraint allows us to get around that. It also maintains separability in the outliner, so objects can also have multiple constraints attached to them. So kind of like what this means is you can't just spam parent on on everything because that's just not really how it works. Um, you want to actually use varied controllers, and also again, if you put a parent controller, that parent controller can be the only parent controller for that object. You'll have to use other constraints for anything else that you want to do. Point constraint. The constraint object will only inherit the position of the driver and not the rotation nor the scaling. So in this case, this is kind of like when we're only dealing with translation. So only moving. Orient will only rotate the object, and then scale will only scale the object if you constrain it. The aim constraint is a little bit of a cool one, where it forces an object to orient itself to another object. In other words, it will point to whatever we constrain it to. So here in the image, you can see that the eye is looking towards this controller that we're moving around over here. So when you move this controller around, this eyeball is going to look directly at that controller. This is the main way to create eyes. Usually it's pretty relatively easy. It's actually really convenient because that way you don't have to like rotate the eyeball around and try to figure out what it's looking at. And maybe like you can just move the controller to an object, and that is where the eye will be looking. So that just makes it a lot easier. Pull vectors. These are typically used when you're doing IK handles. So IK handles have a pull vector, which tells the IK which direction to bend and point. A pull vector constraint will allow us to use the controller to manipulate the direction that your IK handle faces. So if you've done your homework and you've created an IK handle, typically when you click the IK handle, there's going to be a white arrow that's pointing in one direction. Um, and when you bend it down, when you bend your IK down, it'll just bend towards that direction. But you can't move that white arrow. To move that white arrow, you need to do a pull vector. This pull vector constraint lets you move where the arrow is going to be pointed at, and that's way you can bend your knee in different directions, is the idea here. So, in summary, parent will typically do orient, point, and scale, because again, it does all of them. Orient only does rotation, point only does translation, scale only, well, scales. Aim changes the rotation to point towards the controller, and pull vectors control the direction IK bends. Okay, here's a quick demo on controllers here. So once you open up your rigging, once you open up your workspace, make sure you're in the rigging workspace because we want to be rigging here. And here I've just kind of created a simple line of rigs, one FK and one IK, as you can see with my outliner on the side. But yeah, so for specifically the FK, I want to create some controllers for my rig, because again, we do not want to directly animate the rig. So this is really annoying. And if you actually look in the attribute editor, before you rotate it, you see how they're already at these weird numbers, weird values? Yeah, that's typically how it goes. Once you move a rig, it's kind of there. Even if you place it, you try to freeze transformations, it does absolutely nothing. As you can see, I clicked it, and it didn't do anything, right? This rig is still translated at 1.5. So again, not very convenient, but yeah. So there are multiple ways to create a controller. One way is to go to under the curves tab and clicking the NURB circle. So this is what we'll be using, NURB circle right here. You can also go to create NURBS primitive and create a circle there. Okay, So I'm going to hide my model first, and I'm going to move this to my rig. So you could use W and try to move it so it's exactly where it needs to be, something like this. And you could eyeball it. This is probably good enough. But if you want it to be exactly on top of the rig, if you hold V, you'll notice that the center of the moving of the translation turned into a circle from a square. If you hold V up here, if you look up, this lets you snap to points. So it's going to actually snap to the rig. Now, if I want to snap to the other one, it'll go up and down, etc. So holding V lets you snap to a rig. And then what you could do is you can scale the rig up so that way it's a little bit bigger in case you want it to be larger than your object. As you can see here, my cube or my rectangular prism is now a lot smaller compared to my rig. Maybe I'll make it a little bit smaller here. So in our outliner, I'm going to rename our NURB circle 1 to a controller. I'll name this FK bottom control. You can kind of name it how you want it to, whatever is most convenient for you. I typically try to match it up with the name of the rig that it's connecting to. So since this is a FK bottom, I want it to be connected to FK bottom, so it's just easy to remember what I'm attaching this to. Okay, so you want to select your parent or your controller and then the rig. So I'm going to highlight again. I'm going to hide this. So you're going to set the controller and then the rig, and that's how you're going to constrain it. A phrase we like to say is you want to select the driver and then the driven, because this is the driver, this is what's driving, and this is the driven. This is the object that's being driven. So you can think of like a car, you're the driver, and the car is being driven, right? This controller is the one that's driving, and this is the object that's being driven. So this is what we call the driver, and then the driven. Driver, and then the driven. So we select the controller, the driver, and then the brake, and the driven. And here I'm going to press constrain. And on the top, right, under constrain, you already see all the different kinds of constraints that we were talking about. And there are a couple more here that we didn't really go into. If you want to explore those, you can, but we're just going to stick to the main ones. Here, I'm going to press parent constraint options. And if you ever run into the thing where when you attach a controller to a rig and your rig just randomly turns into a random direction, make sure in your rig settings, for any of your rig settings, parent, aim, orient, point constraint, maintain offsets. Make sure maintain offsets is on here. And press apply. Now you notice it doesn't seem like really anything happened, but if you look in the outliner, there's this red chain looking thing. This is a constraint. And you know what kind of constraint you put in, because it literally says parent constraint 1. FK bottom, parent constraint. And then you could, as you can see, if I move the controller now, the rig is moving along with it. Everything in the rig is actually moving along with it. So that's very nice. Now I'm going to add another rig for the top part and do the exact same thing. Whoa. I guess before you actually add the constraint, I also forgot to mention that you need to freeze transformations. Always freeze transformations, and feel free to delete history as well. And if you want to reset the pivot, you can. I'm not going to need to do that here because my pivot's already on the center. And then do the same thing. Select the driver, then the driven, and then constrain. Okay, next one, we're going to call this FK bottom middle because that's what I have it named at in my outliner. And I'm going to do the same thing. I'm going to freeze transformations and delete history, select the driver, and then the driven. And then I'm going to constrain, and maybe I'll press orient for this one. Maybe I only want this to rotate. And now as you can see, if I rotate this, this is also going to rotate, right? It's going to rotate like this. As you can see, it's rotating our rig. We don't have to click the rig. But because in our outliner, there is no hierarchy at the moment. They're kind of in their own layer compared to like here, where you can see there's like obviously a hierarchy where you can open up the hierarchy like this. These have no hierarchy. So actually, if I move the bottom, the controller is going to be left behind. If you want this to be the case, you can leave it like this. Totally up to you. I think for this, in this case, this is kind of inconvenient because if I rotate it, well, it still rotates. It's just locked to the center of like our workspace, and this is just really awkward. So we actually want this controller to be moving with our rig here. And to do this, you actually want to select the child and then the parent. I know, kind of weird. It's a little bit of the opposite. And if you press P, you'll see that now that both of these will be highlighted when I select the bottom controller, right? If I select the bottom controller, both of them will be highlighted. But if I select the top controller, only the top one will be highlighted. And that's just because it's creating a hierarchy, where this one is controlling the controller above it. So if I move this around, the top one will also move, and this rotation will still maintain the same thing. I can also rotate this and rotate this, and it would still be it would also be okay. Um, and I could also, I suppose, I guess again, scaling doesn't really do anything because it's a rig. If you were scaling an object, you could scale it, but again, since this is a rig, scale doesn't actually really do anything. As you can see, it just scales up the controllers, but it doesn't really do anything. Okay, but yeah, that's pretty much the main things about like adding constraints to a controller. I'm not gonna go too much more into this example. I think it's kind of self-explanatory at this point. The other one I wanted to go into is actually the IK handle here. So as you can see, this is the white arrow I was talking about. When you select your IK handle, you'll see this white vector arrow thing. This means if I bend this IK handle, it's going to bend in this direction. So what I'm going to do is I'm going to create a controller actually, and I'm going to snap it to the top here. Let me hide the object, and let me snap it there, and I'm going to call this IK top, and I'm going to move my IK handle here. So instead of like adding a constraint, you could if you want to. I just kind of parent it. I select the IK handle, IK top, and just press B. So now if I move the controller, as you can see here, it'll move the IK handle as well. But notice, like I said, right, if you look at the IK handle, when I bend this down, it's going to bend towards that direction of the vector. And no matter which direction I move my IK handle, it's going to continue bending in that direction. Here. Okay, so how do I actually move the rig so it's actually moving to where I want it to be and not just wherever the heck? It's always like default pointing by default. So this is when we add a pull vector. So I'm going to create a locator. Locator can be found under create, locator that's under free image plane. And it creates this like cross-looking object here. You could technically use controllers like NURB circles as locators for your pull vector, but in this case we'll just use the locator because it's distinguishable. Here we have the circles for our controllers and then these cross-looking objects for our pull vectors. And just like we did last time, you're going to select the driver and then the driven. So select the locator and then the IK handle, go to constrain. You can check this, there's not really any settings for pull vector, and then just apply. So now you'll notice that when I press apply, the green line, rather than going to the top, is now going towards this locator object. And if I move the locator, you'll notice how the rig actually starts spinning. Starts to spin. And before I forget, actually before I even do that, I'm going to make sure I freeze transformations and delete history for our locator, and then constrain it. So I move this, I select, if I bend it, you'll see how it's now pointing towards that direction. And same with this way. It doesn't instantly update for some reason, but once you move the IK handle, it does update, as you notice there. But yeah, that's basically the idea with the pull vector here. It's just making sure that the IK is bending towards where the locator is going to be. And of course, again, you want to move the controller and not the IK handle. But the reason why I'm selecting the IK handle here is because I actually want to show this arrow vector. If I select the controller, you can't see the arrow. So that's why I'm actually moving the I can handle in this case. But normally when you animate, you only want to animate moving this controller like this. And do this, and then maybe you can see, as you can see like there. Okay, so that's it. All I'm going to go over for controllers. Um, if you guys have any questions at any time, feel free to ask in the Discord or come to office hours. Okay, moving on. Steps of rigging. So you want to create controllers, go to create, nerves primitive, circles, or just go into the curves tab and create a circle. Name your controllers, and then you want to place your controllers. Make sure they're matching pivots, or you can just hold V to snap to the rigs. Make sure to freeze transformations. Very, very, very important. Again, it'll make your life a lot easier when you're animating. Constrain the controllers. Order selector matters. Remember, driver, then driven. Driver, then driven. And then maintaining offsets, turn this setting on if your rigs are kind of going everywhere, and then make sure the joint hierarchy is correct. These are some pro tips, but these are kind of also more advanced, so I'm going to skip this for now. Okay, skinning. This is probably a lot of people's part of rigging that they don't really like to deal with because it's very confusing, especially when it's your first time seeing it. The more you do it, the easier it does get, or at least the workflow that you create when you're doing this becomes a lot easier. But yeah, a lot of people tend to struggle during this part. I highly recommend going to office hours instead of spending 10 to 20 grueling hours on your model and nothing works out. Okay, so what is skinning? It's how we tell Maya a joint affects a mesh. How we tell Maya a joint affects a mesh. Okay, I know that sounds confusing, but skinning assigns your model's geometry to its joints and actually allows the joints to move the model. We control how much each joint controls the vertices through a process called weight painting. Getting a character skinned correctly is again tedious and takes a long time. Do not put this off. Some people have put this off till dead week, a whole week before they need to start rendering, and well, let's say maybe they did not finish the short in time or had like an incomplete or unsatisfactory short that they were not happy with. So do start skinning early, and again, we recommend going to office hours. So how does skinning work? Skinning assigns each vertex to be influenced by joints with varying degrees of intensity. For example, your character's head might be mostly influenced by their head joint, but you still want it to form a little when you move their neck, right? So, although the head is mostly being moved by the head joint, parts of the neck should still move with the head because you want the neck to move, right? The head doesn't just move by itself in real life. When you twist your head, parts of your neck are going to also stretch or move around. So why is it important to do skin painting? Well, here's an example of bad skinning, right? If you look on our right over here, even though we're moving the left leg, or could be the right leg depending on which way you're facing, um, the other leg is moving with it, or at least the feet are. And this is because even though we're selecting this leg, this specific weight, some of the other parts of the leg are being skinned together or are under the same influence as these joints. If you're still confused by what I mean, don't worry. I'll go over it in a demo, and hopefully that will clarify a little bit more of what I'm trying to talk about here. So yeah, this typically happens with auto skinning. Um, it's gotten better over the years, but sometimes maybe you get unlucky and you do have a model that's kind of like this. But generally, I will say that auto skinning does make like a model somewhat usable. But I don't know. I've never had really good luck with the auto skinning, and I've just had to reskin everything myself. But skinning can be fun. So, okay, here's this paint skin weights tool. This is joint select, so this is why it's also again important to name your rigs. So that way you actually know what the heck you're clicking. If it's just all rig 1, rig 2, rig 3, rig 4, it might not be very obvious where you're going to be selecting your kind of rig. But yeah, again, Very, very important. Please name your rigs. It'll make your life easier, unless you don't want it to be easier and you want to challenge yourself. But yeah, please name your rigs. Other things, here are paint operations: add, replace, smooth, and scale. We don't really touch scale too much. We usually just use typically these three. So if you want to select the joint, select the tool that you want to use, and then you're going to paste skin weights based on that tool and that joint that you selected. So weight gradients. This is typically to show how much influence a joint has. Usually it's a max. It's only a max influence of 1 across all layers. What this means is, well, in this case, well, first off, let's talk about what the colors mean. White typically means 1, or very, it just means it has a lot of influence. It doesn't have to be 1, it could be like 0.90, 0.95, etc. And here, when it's black, that means there's no influence, meaning that if I were to move this part of the rig, these fingers will not be affected by that movement. But yes, when I say a max influence of 1, this is across all layers. So you see how these currently are black, these are 0. On this layer that is currently selected, it is 0. But if you were to go on a different layer, this could be 0.5, or it could be 1, or 0.75. It could be a different number. But it's going to add up to 1 across all layers. You can't have it add up more than just 1. It can't be 2, can't be 1.1, not 1.0001. It has to be 1. Typically, I recommend using the color ramp. It's a lot easier to visualize what the heck the weight is in that specific joint if you're using the color ramp, right? Blue typically is like around like 0 to 0.1. It's green is like maybe 0.2 to 0.3, 0.35. Yellow is like 0.35 to 0.5, 0.6. Orange, etc. Right? It's just a lot more easier to tell. Here it's all gray, darker gray, lighter gray, right? Darker gray, black, white. So it's kind of hard to tell what that exactly means. If you do want to just use a grayscale, you can. I just prefer using the color ramp, and that's what my demo will show. So yeah, here's the skin tools. Add just adds to the amount of influence on the vertex. Skinning is typically done always on the vertices, and is never done on the faces. It's always on the vertices. All information is stored on the vertices. But yeah, adding will add the number that you're currently adding. So if you have your add setting set to 0.25, it will just add 0.25 to that specific vertex on the layer that you have selected. If you have it add 0.001, it's going to add 0.001. That's not really going to do anything, but it will add that much. Replace will switch the influence. This is mostly used more for like subtracting, so this is kind of the opposite. You could also just add a negative number, and this will also subtract as well. But replacing will replace it directly to whatever number you have. So what that means is if you want this joint, so let's say it's currently 1, right? And you want it to be 0.5, you could set your replace to 0.5, click, and it will just change it from 1 to 0.5. That 0.5 weight will go to a different layer, and maybe it might not go to a layer you don't want. That's why it's important, which we'll talk about in a little bit, why it's important to lock layers. Smooth softens the difference between multiple influences. So what this means is between like this influence and this influence, it'll kind of like take the average and try to like smooth it between. So that way it's like kind of like it has like a smoother gradient, and that way the rig doesn't move too drastically. It's if you want like softer bends rather than sharper bends, then you'll typically use a smooth tool. Or if you want to just kind of relax the influences between different joints and layers as well. The hammer tool. So this is a tool that is really useful when you have a random kind of like skin weight on one specific vertices that's just being really stubborn. You're trying to click add, you're trying to subtract, maybe replace, you're replacing with 0, and it's just not getting replaced. Then what you can do is you can kind of just literally go to vertex mode, select that vertex, go back to the paint skin tool setting, and just press the hammer button. What this does is it quite literally will match all the vertices around it and take like the average of that and then just hammer it down so that way it doesn't stand out, and we'll just have it be equal to the different vertices that are around it. So in this picture, You can see how this has like an influence of 1, and everything around is an influence of 0. By selecting this vertex and pressing the hammer button, it goes down and is now set to 0. That's pretty much what it does. And if it's still being weird, or if it's another vertex that's being weird, just hammer it down. It's the easiest way to make to get rid of like random skin weights that are just being really stubborn to click or not, or cannot be just removed via the regular paint skin weight tools. Okay, so this is why it's important to log influences. I know there's a lot of text on this slide, so just bear with me for a little bit. Each vertex on your mesh again can have a max influence of 1 on it from all joints together. I'm emphasizing this a lot. I know I've been saying this a lot throughout this entire skinning section. But vertices have to add up to 1 influence some way, somehow. Whether that joint is the arm. So let's say you're trying to fix your arm, right? You're trying to fix the arm skinning, and maybe you have the shoulder set to 0.5 when you move the elbow. That other 0.5 could be anywhere. If you do not lock your influences, it can go anywhere. It can go to the feet, it can go to the thighs, it can go to the head. And what happens is when you move the leg, the arm will also move at the same time. Like parts of the arm will also move, even though you're not moving the arm, you're moving the leg. Why does this happen? I don't know. Typically, Maya would choose the nearest joint, and it's pretty smart about that. But sometimes if you're working with bipedal or quadpedal animals, or your arms are really close to your legs, maybe the character that you're creating has really long arms, and it's like the arms are really close to the legs, it might move that influence from the arm to the leg, or move it to the hip, move it to the head, depending on where your arms are. By locking influences, so if you lock certain layers or certain joints, it can't go to those joints. That specific joint that you locked cannot change. It will stay locked, and Maya will try to instead move that influence somewhere else. But if you lock too many joints, then Maya will just not do anything when you skin anything because it doesn't know where to move the extra influence because it has to add up to 1. And yeah, this is kind of what I was talking about. If you remove influence from one joint, I will try to add it what you remove to another joint. This is used to frequently guess wrong, but it's gotten a lot better again. It usually will just choose like the nearest joint in the hierarchy. But yeah, to fix this, you want to lock all the joints, but the ones you are removing influence from and the joint you would want the influence to move to. So typically you'll have like 2 to 3, maybe even 4 joints that are unlocked, and the rest of them should be locked. So here, if you were to just look on a grayscale, right, in a heat map, let's say something is currently yellow, that means on a different joint it'll be like cyan. Or if you have something at green, on another layer it'll be green. Similar with the grayscale, etc. Here's some bad examples of skinning. As you can see here, like the chin is being stretched when the grandma is looking up. Here, kind of like the face is completely being ripped apart. The arms here is being ripped apart. The arm is also being ripped apart again. The head kind of disappeared here. So yeah, please, 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 please fix this. And here's a good example of what good skinning will look like. So here you see when we move the head actually shrinks. And that's because influence from the chest is being affected, so it's actually trying to bring it down towards the chest area. Here in this case, when we fix the skinning, the head stays the same and does not actually change shape. Okay, skinning demo, I'm going to pause the recording. Okay, so we have our model, and it's been rigged, and now we want to skin it. So obviously, you know, it's a pretty simple object, right? Not a lot of influence here and there that you're going to be using. But I just want to show how the skin weight tools kind of work in a simple model, because I think once you start getting to more complex models, it kind of gets hard to tell like what you're really doing and what you're really looking at. So I'm going to hide these rigs for now, and no, I don't want to hide the rigs. I want to hide the controllers. Um, so what I'm going to do is I'm going to go to skin, paint skin weight. So now you can tell a gradient already appeared here. And if you go to the right, you'll see your tool settings. These are the different rigs which is why, again, very, 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 very important to name your rigs. The names here should match with what you're seeing. That means you have selected this model. And you want to select your object and not your rigs in your outliner, otherwise you won't see any color. But yeah, you'll see here. Here I already have my color ramp turned on. Under visualization tab, the geometry color, you can turn on the color ramp or not. If you don't want to have the color ramp, it's fine. I prefer to use the color ramp. But as you can tell, you can see here from our scale. So this red circle is your brush. So if I actually click anything, it's kind of huge, right? It kind of just colors everything. Um, I have everything. I have currently a smooth cycle selected. That's why you're not really seeing much change. But if I have add on, right, you see how it's like adding kind of everything. Uh, we don't want to do that. We just want to. I just want to check first before I do that. But typically, don't want your brush size to be this big unless you're like trying to color the entire face in one sweep. Holding B and dragging left click will shrink the size of your brush. You can also change the shape of your brush and how your brush works using here. I usually just stick to this one though. Um, and of course, on this model, it doesn't matter as much because there's a lot less vertices. But once you have a model with like maybe over 1,000 faces, it starts to matter kind of like, do you want a gradient? Do you want to just have a circle brush? Do you want to have a square brush, etc. Um, so, as you can see, there's already some kind of like skinning, right? And this yellow in our color is like right around here. This is maybe like 0.6 in terms of skin weights. And if I go to top middle, which is the next rig below it, you'll see how it's still yellow, which means this still has some influence. So maybe it's more like 0.5 or zero point 0.4. And then if I go to middle, as you can see, it turns blue. Blue is basically 0 in our case here, right? Because that's what the color ramp means. You can even check it turns black, um, etc. Right? So if I keep going down, all of this is kind of yellow until you reach the bottom where it's actually more red here, which means this has like almost an influence of pretty much 1. Maybe like 0.95, 0.98. It's just really high, so that means nothing else is really affecting it. Um, so if I were to turn on my controllers and I were to rotate it, as you can tell, it kind of like bends inwards, right? You see how it kind of starts to bend in, and maybe you don't want that. Maybe you don't want it to bend when you're bending this specific controller. So what I'm going to do is I'm going to paint skin weights, and maybe what I'm going to do instead is I'm going to set this entire bottom one to just 1. So this entire thing to 1, and then maybe right here to 1. So now, how does that change it? Well, as you can see, the bottom rectangle is quite literally not changing at all when we're rotating this, right? Now it's not bending, it's staying completely solid, and I don't know if that's what you want. If that's what you want, then, continue doing that. Continue doing what you need to do for your skinning. But I'm going to smooth this. As you can tell, my smooth brush was huge because I literally could not see it. Where's my brush? There it is. Okay. So I'm going to smooth this out and relax it just a little bit so that way it's not too rigid. And now, as you can see when I'm bending it, it's not really like bending too far until you start going too far. But by this point, you probably shouldn't really be rotating, or that means you need to go back and add more faces to your object. Again, I'm just trying to show you guys like how the skin weights work here and how they're transferred between layers. Um, but yeah, so if I look at the next layer, as you can see, now it's like yellow, more yellow, and if I add maybe zero point 0.3 to these layers, right, to this specific layer, now there's pretty much no influence from the other layers in this specific section, right? Blue, here's like a little bit lighter blue, so maybe there's still like 0.10 in this specific area, and then I could add more, and now there should be pretty much no influence in either one of these. But you see how it's taking kind of from both, or if I don't do this, it kind of spreads it out to both the rig above it and below it. If I don't want it to go above, I'm going to just lock the rigs above it. And now, any weight I change is going to go to the ones below it. So, for example, if I want this to be now 1, and I click this, now you can see it's only changing the specific one, And inversely, if I were to add 0.3 to this, now it's going to take away from here, from the other layer. But it cannot change anything from these three layers because they are locked currently. Those three layers cannot change at all. And here, fk bottom kind of turns to 0 if I just kind of set these all to 1 just for experimental purposes, of course. As you can see, it's only taking from fk bottom and nothing from fk middle or top. So yeah, that's kind of the idea here with this rig. And maybe it's kind of hard to create an example for the hammer tool. But something you could do is I'm going to unlock all of these. I'll select FK bottom, and what I'm going to do is I'm going to add specific vertices all the way to 1, right? And maybe you don't want it to be 1. Because if I go back to the object, payment skin weights, and I'm going to actually select my vertex here. Because this vertex should not be moving, right? We're selecting the bottom joint. This top joint should not move at all. You can select this, go to your paint skin weight tool, go to FK bottom and press hammer, and it should hammer down a little bit. But again, because both of these vertices were affected, you can kind of select both of these vertices, go back, and then kind of hammer it down until it matches the others vertices, and now it's back to blue, and the bottom should only be kind of skin weighted for this specific model. Other buttons that could be useful, here's the flood button. This is if you kind of want to reset your skin weights, to be honest, or if you're only doing selections. So what I mean by selections is if I go to vertex mode and I highlight these specific vertices on the bottom here. Oh, let me hide my rig so that way it doesn't prioritize selecting that. Vertex mode. Select these 4 vertices, or actually let's select even more vertices. Let's select all these 6 vertices, right? And I go back to my object and I go to paint skin weights. Oh, I think I deselected it. Go back to vertex mode. Let me hide the rig here. Vertex mode. Select your vertices, and you can see now these vertices are specifically highlighted. If you press flood, it will only add whatever your current value to those skin weights and whatever tool you're using. So if I do 0.3, it will flood 0.3 to all 4 of those. If I replace everything to 0.49, then it will change everything to 0.49. If I want everything to be 1, there'll be everything to 1. And it's only going to be to the vertices that you have selected. If you do not have any vertices selected, so if you're in object mode and you select the entire object and you press flood, it will actually add it to every single vertices in the object. And this actually gets rid of all the skinning in every single other layer. So be careful with the flood tool. You don't want to undo everything that you've been working on. But it's pretty nice if you're just selecting like specific sections of your model and then just wanted to quickly add a specific value to that area. And then what you could do afterwards, you can kind of do smooth mode. So I'm going to undo that. Because remember, what smooth does, it kind of takes the average between the 2 layers beneath it. So here's 0, here's like 1, so it should add maybe like roughly like a half. And you can kind of just smooth it around. So that way it makes it a little bit more relaxed and not too intense in the bends. Okay, so that's the skinning demo. If you have any questions about skinning or rigging, I recommend asking in the Discord. So, but yeah, here's a summary. We use constraints to tie controllers to our joints. There are different kinds of constraints that we need to use depending on the situation. Skinning is what combines your skeleton with your mesh, and skinning can take a long time. As you can tell in that demo, I did take a bit of time explaining everything, so could be a little bit confusing. But yeah, feel free to ask any questions. So, in summary, this is you. You interact with controllers. These controllers are constrained to the skeleton, and this skeleton is skinned to your model. That's how rigging is in a very simplified understanding of what we're trying to do and accomplish with at least this class. If you would like to learn more about rigging, we actually have some resources that we'll talk about in a bit. Um, these are some skinning settings. You could just follow them. They'll be in the slides. But yeah, here's some resources. Rig It Right. This is actually a book that's free for UC Berkeley students. It has websites with downloads to their rigs, though it's a little bit dated because it's a bit old. But yeah, feel free to check that out. You can also take and CGI. Their YouTube channel is very nice. They have a lot of skinning tutorials, and it can help you out a lot if you're interested in learning more about rigging. Your homework, well, just go to the grade scope. Should already be on there, but it's a rigging 2 lab. We have a walkthrough video in case you're struggling with it. But yeah, doing this correctly can be difficult. Come to office hours if you have any questions. Don't take 10 hours doing this homework assignment. It should only take you 2 to 3 hours at most. And yeah, thank you guys for listening to this lecture. Bye.